Okay, this is the trig graph question, and they give you a graph in this 7.1. They tell you that f of x is minus 2 sine x. And between minus 180 degrees and 180 degrees, they tell you that this graph has been graphed, and there it is. It should make sense because look at the amplitude. The height of the wave is 2, and instead of going up, it goes down because it's minus 2. So it's kind of flipped. It's reversed. Instead of going 0 and then 90 and 1 or 90 and 2 would be the sine graph, it goes down. So hey, it's making complete sense. Okay. Now, what they want us to graph is not cos x and not to 2, but cosine of x minus 60. Now, if you have a picture, you don't need a calculator or anything else if you know that cosine of 0 degrees is 1. It starts at 1, and then at every 90 degrees something special happens. So the basic cosine graph would look like that, 190 minus 1. That's important to see the basic cosine graph because minus 60 means the way any function would be inside this bracket. If you subtract 60, you go 60 to the right. So I'm actually thinking about the cosine graph shifting 60 degrees to the right, and there you go. That's where you're at. I must go 60 degrees and up there. There's my first point. Now, if you read the fine print, they want the turning points graphed. And if I think it's nice to label the graph and so that the examiner can see exactly you know what you're doing there. Now, every 90 degrees, something special happens. So we add 90, we add 30, 60. That's 150 degrees right there. That's the x-intercept. Now, often they like the endpoints. They didn't ask for it here, but it'd be 180 and minus a half. You put in a 180 there, you'll get minus a half. Now, this intercept should be put in, I think, for sure. And if you put in 0 degrees, if you put in 0, the cosine of minus 60, that should be labeled a half. I think that intercept should be there, the x and y intercept. What did they put over here? Yeah, x and y, anyways. Okay. Now down here, you should be, that's minus 30 degrees, 30, 60, 90. You need to have hit right there. And that's minus 120. So that's a turning point. You got to have that. And minus 180 is an endpoint, and it's actually minus a half there. Now, I did it on a computer and took a look at it. I like to label the turning points and label the endpoints and made it clear where it crossed at 30 and 150. I guess if you did it properly on the graph, it'd be okay. They'd be happy with that. Let's look at the last part here. It doesn't take long to do. Write down the period of f, if it was this function f that's going minus 2f. But if we, instead of had x, we had 3x. 3x. Well, you just have to know, what do you do to the period, which normally it'd be 360 degrees. If there's a 3 in front, you divide it by 3. The new period would be 120 degrees. That's all there is to it. The period's 120 degrees. Use the graph to determine the value of x in which f of x minus g of x is 1. Well, there's f, and I might look here. Hey, that looks like it's 1 between f of g, but f minus g here would be negative 1. The only place that works, there's f, there's the function f, there's the function g. The only place where it looks like 1 unit, it's right at minus 30 degrees. Now this is a question that just tests your ability to transform a graph, you know. Like here, right here, it says there's a new function here. Instead of g of x, well, there's g of x, the one that we graphed with the cosine thing there that was over there. What happens if we took a half? If we made it a half? Or even first, let's say, what happens when we go plus 1? Well, instead of going through here, the whole graph would move up. I made a green line here to show you. That would be the center of the new graph. Or I'd say the line where the wave goes, kind of the axis of symmetry of the graph of the wave. Everything would move up 1. and then it says a half. So it would move up to here, but instead of having an amplitude of 1, which G does, an amplitude of 1, it'd have an amplitude of a half. So the highest it would get is 3 halves, and the lowest it would get is a half. So that's why there's its range. It would go between 3 halves and a half. And all I had to do is I knew what adding 1 did. It took the graph and moved it up 1. And I knew what a half did. It changed its amplitude. So the whole graph shifted up 1. And now instead of going up, if there was no change like a half, it would go up to 2 and down to 0. But it's a half. So it's 3 halves and a half. I can just visualize it and write out the answers to those questions. They're not so hard. If you know what the words mean, period and range and all that kind of stuff.